Hello, welcome to my notebook. This is a reference guide for practitioners and individuals to look up vitamins, minerals, and the RDA recommended daily allowance. So I have a use case here where I believe it will help individuals and practitioners manage their data, give them a reference source, whether it's internal or external from the web, and allow them to incorporate some mechanism to look up documents or data or prescriptions, maybe specified or predefined recommendations on how to take medicine or when to take medicines and if they overlap. So this should help incorporate some use in an application or maybe a chatbot later on where you can schedule and call up the information as needed or amend it and refine the data, whether it be from internal document sources or online sources. So I've illustrated different methods here using Gemini, and I think we can begin. Thank you. So just to reiterate the above use case, medicine often contains a vast number of vitamins and minerals listed on the packaging, and individuals may find it difficult keeping track of their daily intake and prescriptions. Understandably, individuals may find it difficult doing research or manage their range of medicine and vitamins to stay healthy. Practitioners may have stipulated certain requirements around their recommendations and prescriptions and would need the ability to effectively call and look up their records and expand their recommendations. Research may also vary and further advice and data may be linked to specific vitamins and minerals. In this notebook, I explore how individuals and practitioners can incorporate data and use GenAI to solve the problem and not only prioritizing a practitioner's predefined rules, but also expanding out and using GenAI to solve queries and provide the means to query documents separate from the web. This can be dedicated files constructed for an individual or allow practitioners to hold their own data. So just additional information. The code labs have been updated to use Gemini 2.0 family of modules, and this is referencing the course material that we've covered. The Python SDK has been updated to use Google Generative AI to the new unified Google Gen AI SDK. I had a bit of an issue there swapping them over, but I've included those notes here, so hopefully it's an easy reference. So just to begin, I have my basic import here to use Python, so we're using NumPy and Pandas. We import OS, and yeah, we move on. So I've installed the SDK, installing for ChromaDB and Gemini API Python SDK. As you can see here, I've pip uninstalled and I've installed them again. Yeah, so there we go. It runs through the query. Jupyter Lab is not installed. You'll see lower down that I have installed later on, and we'll just run through the output. Requirements already satisfied. I have run into a few queries that I've removed where I had to upgrade the pip install, but that's no longer needed. I've left it here for quick reference to note on the blog. Over here, we go on to import the SDK and some helpers for rendering the output using the Google Gen AI and the import types. So we've got the ipython.display import for HTML and Markdown display, and then we import the ChromaDB. So what I've done here is also included the Gen AI version for quick reference to this, and we begin. So the Chroma creates collection, as you can see here, where we will store the embeddings, documents, and additional metadata. collection index the embeddings and documents, and enable efficient retrieval and filtering. So that's very nice. So over here, we go on to our collection. We've just added it to my collection. And we find that we've got a bit of a helper here. So we've got the print collection name. As you can see here, my collection has been created. It already exists, but in this case, it's just been created since I've run it already. And then we move on. So what else do we have here? We get the existing collection instead of creating a new one. You can see we are already using the existing one, my collection. And yes, so we don't need to delete the existing connection. And I'm not starting afresh, so I've excluded that, but it's nice just to reference since we used it. I suppose we won't need this anymore. Okay. So just a side note, uncomment the below line to create the collection after deleting the collection previously. Yes, we don't need to do that because I haven't removed it, but if we do, it's easy here just to unreference or uncomment and it should be back. So yes, let's begin with the use case. In this example over here, I've just done a simple example based off of the course material where we've incorporated documents referring to vitamins, a document referring to chemicals, document referring to minerals. And in our query, we have here query text. This is a query document about human daily intake with regard to vitamins. So essentially, this result here is only returning one result off of this, and it's looking for the closest match to that being vitamins. So we should have our ID 1 returned, and that's what we see here on the output. We can furthermore inspect the results, and what we see here, we've referenced all three documents, and what we can see here, the distance from our search query on human daily intake with regard to vitamins is the closest match to 1 being document ID 1. This is a document about vitamins, whereas document 2 is further away, as we can see, not close to 1. So our closest match is document ID 1. We can expand this to be more precise and incorporate it with something where we would have more detailed documents, and when we need to refer or look this up, it gives us a better distance measurement, and that's how we're going to retrieve our documents and link it. So moving on, we've got our automated retry below. This is to assist with the per minute quota and system usage. This was advised in the 5-day course, and I've incorporated it here as a helper. So yes, maybe we should go through it. I'm not too sure, but we'll move on. Can also include the API key that we've set up. Add-ons, secrets, we had our Google API key, just for quick reference. And yes, as you can see, I've run this from start to finish, and we'll work through it together. From here, we've got available models. So this is a very nice reference. Over here, we're just using Gemini 2.0 Flash, and I've asked, just to test the connection and the API, that we please count to 10. Very straightforward, and it does that. So we first querying our embedded contents in the supported actions for the module list, and as we can see here, it's connected with the API and it begins. Okay, here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then it says these are the models available with regard to the embedded content. Okay, so for reference, I like to include what model we are using. So I've just printed it out here, and it says model Gemini 2.0 Flash live 001. So that's a very nice reference just to see what we're using. And we move on to the use case. So to begin with, we've got embeddings and similarity score, where we calculate the similarity scores. In here, I've added a quick reference to vitamins, something with a bit of a spelling mistake, and then again with minerals and chemicals, and then just a bit of extra information, glycemic and glycemic index, as well as reference to vitamins and minerals are both micronutrients, and then an alternative comparison, something with vitamins listed in, and then something completely unrelated, just to give us a better illustration, unrelated text, nothing about vitamins, minerals, or chemicals, or glycemic index, but it does say, is breakfast the most important meal of the day? So this is just to illustrate what information we could have and how to measure it. As we'll see here, moving lower, we've got a helper function that makes it easier to display longer embedded text in our visualization. For example, this is our longest embedded text here, which is our alternative option, and we'll see as we go down to the scoring. Do we work with this? No, I don't think we need to, but we've chosen color green. So in our heat map using Seaborn, we can see that vitamins, even with the spelling mistake, is clustered together as a darker indicator, a closer measurement, since they're closer related. And further down, we can see vitamins in our sentence is also darker green with vitamins. So it's given us our measurements. We can further query that, where we pull in our actual calculation. So we've got our sim sort value, and we have vitamins giving us an exact or a very close match as 999999, where vitamins with a spelling mistake is slightly off. Then thirdly, our vitamins and minerals being in the next best option, falling just below that. Something unrelated being minerals. We do have minerals listed here, so it falls a bit higher than the rest. And then our unrelated one, glycemic, chemicals, and so forth. So essentially, it's ordered it by its closest match. Very easy to illustrate and see when we look at the values. Yes, so classifying embeddings with Keras. So how should we begin here? I had a bit of an error that I've noted here. This can be ignored. As you can see, it's already been registered. All message before this is called, is written, is unable to register. All of this is attempting to register the factory for plugin, whether it is CUDNN or CUFFT, or the third one, CUBLAS. They all trying to be registered, but registered as a factory for the plugin when one has already been registered. So that we can see here. It appears we can ignore that. I don't think it's going to interfere. It's going to load the data anyway. So yes, I have a bit of a workaround here, but I don't think we need to use that now. As you can see, I've imported TensorFlow and printed the version for reference, where it's 2.18. Okay. So, importing Keras as layers, or from Keras importing layers, and then what we see here let's see. I suppose I should describe this here, where we illustrate a classification model that can be used by practitioners to source and refer to documentation pertaining to a particular resource. So that's very helpful. If we expand on this, we can look at the document data example, where we have an embedded database with document 1, 2, 3, 4, and you can see some are referring to vitamins, others amino acids. We can see we have a makeup of quite a bit here. And then the fourth document is more of a neutral document, where we've just stipulated a bit of information unrelated to minerals, chemicals, or vitamins. So using the embedding database with ChromaDB, we have a function where we generate the embeddings with Gemini API, where we have a retrieval system. As we can see here, we've got ChromaDB, Google API Core, and yes, we have a retry helper here for the per minute quota, and this was illustrated in the course content, so very helpful. So we can move on. Yes, so where are we? Import ChromaDB. We've included the database name, and we can look at our collection. You can see here we have a deprecation warning. This can also be ignored. This will be required in a future version, but for now it's not an issue. We will confirm that the database is inserted by looking at the database and providing a document count. So as we see here, just looking at the database, we've got a count of 4. Going up, it refers to our documents listed above here. Then, moving on, we can retrieve the relevant documents, where we have a query here saying what are amino acids, and it works through the documents and finds the closest match to that document. This one being water amino acids. We can go back here and you'll find that right above here, document 3. And then furthermore, if I move back down, so augmented generation to answer the question, where we have just a nice illustration here. This passage is from a single document, just to show what we're looking at. And as you can see here, we had our question, what are amino acids? And that question will be populated, query 1 line, and we will get our result returned. This passage is from a single document. The question was, what are amino acids? And here we go. Here's our passage from the document itself. So this is a great use case if we have medical data, maybe a prescription. Maybe we make notes that we are only supposed to take X amount of vitamins. This can be referenced and pulled up. And we can change the query. Maybe it's not amino acids. Maybe we are looking for vitamin D, or something like iodine, or something more abstract. But magnesium's a good one. I particularly like magnesium, so that's a good one. And there we go. So moving on, we can go and use the markdown to provide the answer, and Gemini will use this information, and then based on the passage, amino acids are exemplified by glycerin and can't really pronounce that, leucerin. So it gives us a bit of a markdown and a prompt. We can expand on this as we need. You'll see lower down we do go a bit more in detail on getting a better prompt. And yes, so let's start a chat and recall a conversation. In this case, I'm using my name just to better illustrate the recall of the conversation. So we'll first send our prompt through. Hello, you can call me Robert. Okay, Robert, it's nice to meet you. How can I help today? So that is just to illustrate that this is the point in time I'm giving my name. And if we proceed with the prompt, we can say here, can you tell me the difference between chemicals, vitamins, and minerals? It's very simple, very straightforward, and we get a direct and informative response. Here's a breakdown between the differences, and you can see here chemicals, vitamins, minerals. It's quite a lengthy breakdown, and then it also goes here in simple terms. Chemicals is everything, and you can see we get a bit of a better understanding through a very straightforward prompt. I hope this explanation is helpful. And then we move on where we can maybe want to recall the chat. So let's have a quick look. So the chat object's alive, and we have a conversation state. And we can see here, do you remember what my name is? And can you repeat the last response, but in summary? As you can see, Gemini recalls, yes, it's Robert. I remember your name. And here we go. We've got a summary of everything we've asked before. So very detailed to very summarized response very easily. So we could change the model and get a different response. And I've chosen here just to illustrate that. So we can see here, we've printed all the available models just for quick reference. Very handy and fun feature. Moving on, we have our output length. So this is pretty fun. In this instance, I mentioned write a 785 word essay on the importance of the glycemic index with regard to the human nutrition. But you'll notice my max output token size is 300. So we do have that limitation. We've got 785 words, but we've limited that. And as you can see, it cuts it off because we've hit our token at 300. As a result, we don't get anything beyond that. So where we can optimize that is request that we write it in a summary. And as you can see here, we get that summarized version right away. So a very easy way to utilize output length differently, and it's pretty adaptive, so it will take some playing, but it does give us some control. And then what we also have is a bit of a note on temperature, a note on top P, and we can use that in the use case below. So in this instance, the story prompt, you're a well-informed nutritionist, write a short story of the glycemic index, and you can see here temperature of 1, top P 0.95. So we get a very nice response. Okay, let's do that. Get a setting and an explanation and a little story from Gemini 2.0 Flash. Then we can move on to a zero shot or few shot prompt where we have our zero shot, also temperature 0.5, top P at 1 with an output token size of 300. And as you can see, here's my zero shot prompt. It's a single prompt where we go classify the volume of water consumption as positive, neutral, or negative, where we review this information, where we can use as a reference to what it should be. And if I quickly show you here, we have, unchecked. I have only had 4 liters of water today, and as you can see, Gemini analyzes this. We get a neutral classification, and here's our explanation why. I've asked for the explanation, explain why in summary, and as you can see, we get a very nice summary of how we got there and a sentiment analysis. So the enum mode, where we can expand on this a bit. All I've done really is illustrated the neutral response that we've received here. And furthermore, I've utilized the same output where we've printed the sentiment as neutral and the enum sentiment. So we've passed that response. Moving on from one shot and few shot check, where I've illustrated a few shot prompt here, where we've passed individual vitamins and minerals pertaining to a daily intake or recommended intake amount or dosage in a valid JSON format. So here we've got multiple examples for our few shot, where we have specified gender and age and intake, an amount, a dosage, and a time. This is incredibly helpful, especially if you have overlapping medication where maybe you have to take multiple in the morning. Maybe it is one vitamin that's the same as another vitamin and they have overlapping values and you exceed your daily amount intake. This will give us the structure we can actually use to control that output or response and feedback there. So again, we just go through our multiple examples, and from here, when we process this, what is my daily intake? As you can see, our response comes back in that same format. Daily intake, I am a woman age 41 and need to take 2 vitamins in the morning. This is 40 milligrams of vitamin D with breakfast 5 a.m. and 1 in the afternoon with dinner at 7 p.m. This is a 75 milligram of magnesium. So here we go, vitamin 1 and vitamin 2, 2 milligrams, 40 in the morning with breakfast, 75 milligrams in the afternoon with dinner, and then it gives us our time, morning at 5, afternoon at 75. So great utility right here. It can be used in almost anything, an app, a chatbot, whatever it may be, gives us some control, get the feedback, store it in the data, and we can use it in anything we need. So using a JSON mode, as you can see here, I've imported individual intake, and we've determined gender as a string, age as string, intake as a list and a string, and there we go, we get our feedback. Now I was pulling this over male 25, let's see here in the example. I need to clear the data, but this is just an example, and you can see it gives us in our list right there. So moving on to our chain of thought, this is great. As you can see here, I've got a bit of a description of the process. I have my prompt. I'm a male age 51 and need to take 2 vitamins and 1 in the morning. After eating, this is 50 milligrams of vitamin D and 1 at night. With dinner, this is magnesium 200 milligrams at 9 p.m. What is the recommended daily intake for each vitamin? Now, this is just an example. It's not real at all. It's just an example. So what we have here is Gemini going through the information. As you can see, it gives us everything we need to look at. RDA, recommend daily allowance, gives us our breakdown between the age, and it fulfills that answer in detail, comprehensively, and very simply. Furthermore, we want to change that prompt and say, what is our train of thought? Let's think step by step. In this example, excuse me, it uses the same process. As you can see here, it gives us step 1. then step 2, step 3, step 4. This way it gives us a great breakdown of exactly what we're looking at. Maybe as a practitioner, you would want to see this information on this level opposed to an individual who would like or prefer the previous response over here. So that gives us the data in different ways, gives us the thought process, the chain of thought, and allows us to actually look through what we need. In summary, at the bottom, gives us quite a bit of information to work with. And yes, we can move on to react, reason, and act. So in this example, we just illustrate Gemini API to perform the searching steps. As you can see here, we've got our model instructions. So interleveling thought, action observes steps, and essentially what we can do is work through this method. We have our example 1 here where we have our question and our thought process 1, our act process 1, observation process 1, and within each we have the condition. So for example, in action 1 we have our search. This is telling us what to search for. In action 2 we have our lookup. This is telling us what to look up. And as you see, you work through this process, it's going to go through each one of these steps until we reach the finish at action 3. Here's another example where we take the same methodology and we go through the same thought 1, action 1, observation 1. This breakdown then goes through, it gives us our information here on observation 1, but we can go over to thought 2, action 2, do our lookup, our observation 2 comes through, gives us more structured detail. This can be manual, can be brought in, but this is just for quick reference. And then as we go through how much is vitamin C for female, goes through our observation 3, gives us exactly this information, doesn't say anything about a female, but it does mention a pregnant lady, so we have to go here. This is for pregnant female. I need to instead search woman. So there we go out and we search how much vitamin C per day for a woman, and there we go. So not a pregnant lady, but just a lady, woman. 75 milligrams in general. Experts recommend a woman get 75 milligrams of vitamin C a day and men get 90 milligrams. So it gives us a bit more, and it gives us the pregnant information. Now if you do a Google research, you'll see it actually takes us through these steps unless you specifically search for that result, and there eventually we'll get 75 milligrams not pregnant. So using that, we can pull through the information with Gemini, and as you can see, I've changed the question a bit, and what it will go through is the thought process 1. You need to find the recommended daily intake from vitamin C for male age 35. That's thought 1. So it populated that thought process for us. And over here, if we go down, back to it, we can see, here's action 1, search, recommended daily intake, vitamin C, male age 35. So that's our output that it's actually given us. Now, the practitioner can perform the research themselves and incorporate it into the observation 1, where they alter the details and give the exact information that they deem correct or whatever they authorize to process. And then over here we go, the recommended daily intake of vitamin C for a man is 90 milligrams a day. Here's action 2, giving us our final result finish at 90 milligrams a day, as we've stipulated in the above reason and act. Okay, so that gives us exactly what we're looking for. Now with thinking mode as an experimental Gemini Flash 2.0 thinking module, this is pretty handy, pretty nifty. I quite like it. So we've just imported it over here, and as you can see, the contents is saying what is the RDA, so recommended daily allowance for vitamin C and magnesium for a lady that is pregnant. Okay, so moving on, we actually get that straight away based on that previous information. It runs through everything. Here's a breakdown, an important context. So you can see it actually goes through that entire process. We haven't specified age, but it does that for us over here. And we've got our vitamin C, our magnesium, and important considerations. Now, as you can see, because this is an AI model, we've got some conditioning, and you have to consult a healthcare provider. And this is exactly why it's so useful, because if a practitioner has access or control in this, in some medium, then they can advise on the complexity, whether it be diabetes or an overlap between medication. So the utility here is vast, and you're able to do pretty much what you need to without being confined to the traditional means, whether it's writing it down or building an Excel sheet. So yes, moving on. Function calling with Gemini API. So the information I provided in this example comes from these three resources available online freely, publicly, and I'd just like to credit and note that here. So here we go. We create a local database with local SQLite database with load XSQL, and then we can see SQLite. We have a sample database. So it's been reloaded, but I like to reload it just in case, or for other reasons, but we just reload it over here. And then we've got our synthetic data that I've created here. As you can see, I've just created the minerals table, vitamins table, specification groups table, and in each I've included everything that would be helpful in this exercise, where we've got zinc, for example, for the age of 1 to 18 years, 11 milligrams, male, and that's 1.11. That's how much it is, the amount ratio. Same with vitamins. We've just specified the vitamin, age, amount, and gender. And there we go. So when we run this, you can see it quickly creates our data. Done, done, done. 3 rows affected. Oh, 3 databases, tables affected. There we go. So we define the database function, and we connect it. Moving on, we list the tables. As you can see here, I've written this down just as an execute, and we get minerals, vitamins, and specification group. Now that they're available, we can start to use it a bit more. And as you can see here, we've got our database call, vitamins, and it describes that data for us. Now, from here, we can go and we can run a select query on the database, just as an example, and then implement function calls and adding it all together in a call to a Gemini API. So here we go. We've got our instructions, just general instructions, and as you can see, we have connected Gemini 2.0-Flash. Okay, I've uncommented some of the notes because it's I've commented out some of the code because we have imported the API already, and I just like to incorporate it here just in case we need to move things around. But moving on, right at the end we have this query where we say what is listed for vitamin C in the vitamins table. And here we go, we have the database call where it's run and executed the code for us directly, and here it is. Here is the information for vitamin C in the vitamins table, and it gives us exactly what we're looking for. So it's quite a powerful tool to generate the code for us in the database directly, as well as control and pull and list whatever we need. That, I hope, illustrates the potential of what we could incorporate this with. I would like to bring this into an app assistant, but due to time restrictions, I think this is as far as I can illustrate this. And thank you very much for your time. I will continue to work on this. Thank you.